JAMSTEC presents Chikyu TV.
Welcome to JAMSTEC Presents Discover the Future, Chikyu TV. I'm your host, Sasha. Previously on Chikyu TV, we reported Chikyu's expedition off the Tohoku region where the devastating earthquake and tsunami occurred last year. Science Party members got on board to find out why the earthquake was so massive and thereby to understand the mechanism behind it. In the first expedition, they successfully recovered core samples across the plate boundary fault at the Japan Trench from about 8,000 meters below the sea surface. This episode covers their second attempt at the other scientific objective to install the Observatory, a set of sensors to measure the frictional heat of the fault that caused the 3/11 Great Earthquake. In July 2012, the Science Party made their way again to the investigation site along the Japan Trench. Now let's get started with Chikyu TV.
Chikyu TV.
前回コアが取れたところまで、達成できたのは良かったんですけれども、断層の温度を測るというのがこのプロジェクトの一つの大きな柱でした。なので今回は、ぜひともこれを成功させて帰りたいと思います。現在、ドリルパイプを下ろす用意をしています。今回のドリルパイプの先端は、前回と同じようにドリルビットがつくわけですけれども、前回の経験を踏まえて今回はマッドモーターと呼ばれる、パーツをつけています。マッドモーターというのは上から入れる泥水によってビットの先だけを回してパイプ自体のローテーションを少なくしてビットだけを回して掘っていくというシステムです。これによってドリルパイプにかかるストレスが軽減されることによってより効率的に掘れるのではないかというふうに考えています。今回のオペレーションは前回セットした穴にドリルパイプを入れてそこから下へ掘り進むところから始まります。前回海底の断層の位置っていうのはある程度確認されておりますので、そこまで一応穴を掘ります。で穴を掘りました後に、前回入れられなかった温度計を入れるということを目的として3週間程度の公開を行っています。
Yeah, to measure the temperature, the frictional heat across the fault zone, we're going to use a number of sensors like this. The sensors that we have consist of a bit of wire that has very sensitive resistance to temperature. So this is the actual sensor, and it's connected to a battery and then connected to a small computer and data logger that will measure the voltage. And so the voltage that we get is related to the resistance of this sensor. and that resistance of that sensor is very sensitive to the temperature. So the voltage as recorded by the computer can give us the resistance and then the temperature. So each one of these sensors can measure the temperature to within a few thousandths of a degree. And this is very important because when we are down there, we are going to be looking for a frictional heat anomaly across the fault of maybe around 1 degree above the background temperature. So once we have the sensors down there, we'll let them record for a few months so that we can make sure that we're really monitoring the true heat of the earthquake. Then we will have to come back and recover each one of these sensors. So each one has its own data logger inside of it and records the data by itself. So we will have to take each instrument back and download the data. And so to do that, we will return with Kaiko's ROV submersible, and it will pull the whole rope out and bring it back to the surface, and then we can download the data.
But if you separate, when a photo, we're going to make this. Differential. So it can let it go up the same thing.
2つですね。
チャートの中入ってるんですよね。深度的には分かってます。これが
About 20 years ago.
That's
About 776 one.
maybe. I think having more room below us is safer for installation for debris.
Evidence of point. Okay. It's very sweet. Yes.
Yeah, I think we're still. And then this one here is not attached yet. We attach this. All these attach. Yeah, I think.
So we want to know the a
Free
little
space.
we needed to calculate the exact length of the region.
Impossible missions are the only ones which succeed.
Oh.
Jacques Cousteau.
Jacques Cousteau.
Jacques Cousteau. Yeah.
Good.
So the only missions that really succeed are the ones that are very tough.
Yeah.
Yeah. Almost impossible.
Yeah. It's challenging.
Very challenging. Yeah. Almost done. Doing some tests on the running tool right now, and I need to quick take a break, get some food in me, and but everything is going well so far.
最後に忘れない 3.11 って書きました。僕らこのエクスペディションで、新しい技術とかオペレーションにチャレンジしてるんですけども、さらにこの目的が、東北の襲った大地震を解明するということで、それに参加できて非常に光栄に思ってます。で僕らは、3.11 に起きたことを後世に伝えていかないといけないと思うんですけれども、我々のこの分野に携わる者としてはぜひ巨大地震が起きた何が起きたかというのを解明して、それを伝えていきたい。記憶を風化させないためにも、僕らが新しい地震の真実を解明して、伝えていきたいという気持ちで、忘れない 3.11 っていうのを書きました。ちょっとうまく言葉がまとまりません。7000m の旅を無事にたどり着くのを祈りましょう。
50度、これですね、20度ぐらい違う感じだったんですよ。オフセット、この間は。オフセット。
20度方向に020で、8メーター分。
海底を主任して、ウェルヘッドを探しに、見つけたらリエントリーですね。7000m 下で、7000m 上の船が若干動いて、当然下のパイプはすぐにはそれに応答しないんで、じわじわと攻めながら最後はウェルヘッドを見つけてリエントリーします。
This is Turkish moving to 050 20 meters.
近くなってきてる。
おそらく今カッティングスだろうと思ってる。
澤田さん、これ
それかな。
だいぶなんか
強い
ギミックな感じになっちゃったですね。
10度方向に5メーター、010 5メーター。
ピカピカの
もうちょっと左のモニター左で電気つけてみよう。よし。
追いつかない。いいよ。いいよ。
リエントリーできましたね。ランディングとリリース、あと2つですね。ミッションコンプリートまで。
This one. This one. This one will be remain. Then they are sticking up from the about 16 inches. But it's color is
Patayin ko muna tapos lagyan mo duct tape pa.
stop.
Aman.
Oh, siya.
Up.
Good job, yeah. We did it. Thank you very much. Yeah, thank you.
Instead of pulling, because that's a triple, just make that into a quad.
So measuring the temperature of the fault was really one of the main goals of JFAST. And we have to measure it quickly. That's why we call it JFAST. So the fact we were able to do it this time, sort of within about a year and a few months after the earthquake, is very important because we can measure the friction that was caused on the fault when the earthquake happened. And that really hasn't been done before. So if we can measure the friction, we can understand the stress, and we can really begin to explain why such a large slip happened in this area. And it was that large slip that caused a devastating tsunami. So it's really maybe the most important thing to learn about this earthquake. So we put the temperature sensors in a few days ago, and they're going to be recording over several months. So like everyone else, I feel relieved and elated that we accomplished one of the major goals of this expedition, which was to put the temperature sensors near the fault.
Chikyu TV.
So let's congratulate them on the success in the second attempt to install the observatory. Obviously, it was a really tough job to install the instruments in such deep sea as 6,897 meters below the surface. They plan to recover the observatory using the Kaiko 7002 remotely operated vehicle this fall or later. So on our next episode, we will show you the latest status of Chikyu, which recently left the port of Hachinohe. Last time, the chief scientist of this project explained us that understanding the actual condition of the deep subsea floor biosphere would deepen our understanding of the Earth's environment. Right now, Chikyu is up to the challenge for sampling from a record depth below the seafloor in the scientific ocean drilling program to access an undiscovered biosphere. Are they going to achieve their goals? You will see that on our next episode, which is scheduled on 3rd of October 2012. JAMSTEC presents Discover the Future, Chikyu TV. I'm your host, Sasha. See you next time. Bye-bye.